Alright, so I hope this is recording. Let's take a look at these variation problems. Now, what I've done here, you can see on the right, I've cut and pasted from our skill packet the key words. When it says direct variation, we think this constant of proportionality, we think multiplication, the k times x. Then when it's inverse, it's k divided by x. And when it's a joint variation, you think multiplication, it's just you have more than two variables. You've got an x, y, and a z, or maybe three different letters. Alright, so let's take a look at problem number 33. We've got that it says k varies inversely. When I see inverse, I think division. So I've got, well, k, q. Q varies in this k and then inversely with t. So there's the equation that they want, but now they want more than that. They also want the k, the constant of proportionality. So this next sentence provides me enough information to figure out what that k is. So they're telling me that when q is 8, that the t is 3. So if I multiply both sides by 3, I can solve for k, and that makes sense that 24 divided by 3 is 8. So this k, this constant of proportionality, is 24. That's what they were asking for, the equation and the constant. Now, most of the time, I think a lot of you are like me, and I just, rather than giving these two separate pieces of information, I just combine it, because k is always 24. As q and t change, k remains constant. So it's always going to be 24 divided by t, and that's how we use this equation. So these two pieces of information, I typically combine them into an equation. Either one of these is acceptable because that's what it's asking us for. Let's take a look at the next problem. It's also a variation problem. Let's bring along our key words here. And, well, I must not have copied and pasted it. I've been having so much problems with this tonight that I've had to restart, and it doesn't always, it locks up and it does not cooperate. Alright, so jointly. Well, that's this last one here. That's telling me that I have more than two variables. So let's see. And I think multiplication. Now notice that k is always in the numerator. K is never in the denominator. Now k might be a fraction like 1/2, where yeah, the 2's in the denominator, but I mean that the k itself, if you think of it as a decimal, 0.5, hey, that's always going to be in the numerator. But anyway, let's take a look at this problem. So, m varies jointly. So I've got m and I've got k, and now when I see jointly, I'm expecting more than one variable to follow, a and b, and I think multiplication, just like I do with direct variation, only with more than one variable. So here is the equation they want. Now they provide me with enough information to determine my constant k. They're telling me that, let's substitute it in, that a is 24, and that b is 3, and the m is 8. So that's enough information for us to figure out what k is. So let's divide both sides by 24 times 3, which is probably 72. We'll check that in a minute because it's getting late and I'm not very good at mental arithmetic. Alright, if I divide both sides by 24 times 3, these factors cancel, and I have k. Well, I know that 8 divides 24 3 times, so this k is 1/9. So I know that my equation is 1/9 times a times b, or if you want to write it as a times b divided by 9, hey, that's okay too, but that k is 1/9. So whether you present your answer as the equation and then follow it with that you have determined that k is 1/9, or whether you write it as an equation, and either of these equations is acceptable, let's just use this one so we don't confuse anybody. So either one of these two answers is acceptable for that problem, right? All right, let's move on to the next two. I think are also variation problems. Maybe the next three. So S varies directly. So from my key words, I know that directly is multiplication. So I've got this S, I have a K that's always in the numerator, and I have directly with D, so K times D. But then when I see inversely, the variable, if it's inversely with respect to X, the X is in the denominator. Well, here it's inverse with respect to M, so M is in the denominator. So there's the equation that they wanted. Now they provide me enough information to determine what K is. They're telling me that S is 4. I don't know what K is. They're telling me that D is 32 and the M is 6. Okay, so let's reduce 32 over 6. 2 goes into 32 16 times, and 2 goes into that 3 times. So now to solve for K, let's take 3 times 4 and then divide it by 16. So let's multiply by the reciprocal, the 3 over 16, because now the 3's cancel, the 16 cancels, and hey, I'll multiply this side by 3 over 16. So I've got that 3 times 4 is 12, 16 times 1 is 16. This reduces, both of those are divisible by 4, so that's 3/4. So I know, and you know, maybe if you're doing it on a calculator, which is fine, this is 0.75. So when we come up to the equation, whether you write 3/4 or whether you write 0.75, it really doesn't matter. So S is equal to 0.75 or 3/4 times D divided by M. Now what they really want is the value of S. S equals, and when they want the value of S, when D is 12, and this should say M, hopefully it does on your paper, and M is 6. So I've got 3/4 times 12 divided by 6. Alright, let's do that over here. 3/4 times 12, 0.75 times 12 is 9, and 9 divided by 6 is 3/2. Is that right? Let's do I don't trust myself. For a math teacher, I am terrible at arithmetic. Yeah, it was 9. Alright. And 9 divided by 6, 3, half of 3 is 1.5. So S is 3/2. So there you go. Alright, let's take a look at these next two. We'll just, since they're all very, I thought there was 2 more. Yeah. Alright. Your distance D from a lightning bolt varies directly with the time t. So with directly, I'm thinking multiplication. So my equation, D is equal to K times T. Alright, now I can, that's all it's wanting is the equation. Now I typically, when given the chance to it doesn't ask specifically for the proportionality for K, but I'm going to have to figure it out in B anyway. Whether I figure it out now or figure it out later, it doesn't matter. So I'm going to use this next pieces of information to determine K. If you hear thunder, 10 seconds, well, T is for time, so that's 10 seconds. When you see lightning, that you're about 2 miles. So this is just an approximation. It's not exact because it'd be pretty difficult measurement tools to measure that precisely. So to solve for K, let's divide both sides by 10. And so K is 2 over 10, but 2 over 10 reduces to 1/5. So my equation is 1/5 of the time. The distance is 1/5 times the time, where the distance is in miles and the time is in seconds. So now it wants me to apply what I've learned to this situation. How many seconds, that's T, will it take for thunder to travel 4 miles? So the left hand side of this is a 4, and 1/5 of t is equal to 4. Well, 1/5 of 20. In other words, if you multiply both sides by 5, 20 seconds. Okay. How many seconds? 20 seconds will it take for thunder to travel 4 miles. So 2 miles is 10 seconds. Double that, and that's 4 miles. Double the time, 20 seconds. I mean, there's a couple of you that said, hey, that's pretty obvious, you know. And it is, so it's not a hard problem, you know. It's not meant to be super hard. Alright, so let's take a look here. The number of girls varies directly, so I'm thinking multiplication, so I've got G, my K is always in the numerator, directly as the number of boys, so that's multiplying by the number of boys, but then it says inversely with the number of teachers. Okay, so there's my equation. What follows next is enough information to figure out what K is. When there were 50 girls, on the left-hand side I've got 50. There were 20 teachers and 10 boys. Well, 10 divided by 20, that's just 1/2. So I've got 50 is equal to 1/2 times K. If I multiply both sides by 2, K is equal to 100. So my equation says the number of girls is equal to 100 times the number of boys divided by the number of teachers. So the 100 remains constant through the problem. Now in this last sentence, the number of boys, the number of girls, the number of teachers, well, they've all changed. It wants me to figure out B, the number of boys. I don't know that, but it says that there were 10 girls. So on the left, that's 10. I don't know how many boys there were, and there was 100 teachers. Well, the 100 divided by 100 is 1, so there has to be 10 boys. So I hope that helps, and I'll talk to you later.